still going. So there are two problems with this shop vac. The first one is the one you just heard, which is a disconcerting grumble coming from the motor bearings. The other one is that there's no suction. You probably heard it spinning really quickly and with low resistance, and that's because that radial fan has actually backed off the motor shaft. And I know why, because I was messing with it yesterday. So in this video, I'm going to continue the tradition of posting completely unrelated videos on my channel on completely random subjects. But today is going to be getting into this old shop vac and turn it apart and making a few improvements to it to make it more reliable. The weather outside was starting to get a little bit bad, so I decided just to bring the business end of the shop vac inside to work on it and show you guys what I'm talking about. So I referenced that it sounded like perhaps the impeller was not really spinning with the shaft. It was stripped out or something happened. I don't know how common of a problem that is, but the reason that I said I was pretty sure that was why is because yesterday I was in there to lubricate the bearings, and there's a little clip that holds that impeller on, and it was pretty rusty, and I suspect that when I put it back, it worked for a couple seconds and then left the chat. So in this video, I'm going to be fixing that, hopefully by cutting threads into that shaft and installing a lock nut to replace the clip. We'll see if that works out. We'll come to that later, but let's start first by general teardown. There's other videos on YouTube which show this process. I'm not going to really go into too much detail, but essentially there's all these fasteners around the base here. They're Torx T25. I'm just going to slowly walk them out with the impact here. And that's going to be step one. So I've removed those 10 little Torx screws, and at that point, we can simply slide this off the top. Noting this is the little float thing that goes in there. The next thing is, well, we really just want to get access to the main motor unit. So, this can come off now. Note, before you go further, you might want to take a couple pictures to see how everything goes back together. And also, for example, the routing of this cord, there's a little notch for it, and you can see it's kind of captured, behind some of these little plastic pieces. So that can move over there. The next thing is, if you look down in here on each side, there's another Torx T25 screw. In my case, there is actually only one installed when I first opened this up. So I don't know if that's a mistake from the factory or maybe they're all like that. But in either case, we need to take those two out as our next step. So now we have access to the actual blower fan here, which turns with the motor, or at least it's supposed to. You can see the clip that I was referencing earlier. It's clearly seen better days. And if you look really closely, you can see a shiny groove from what can only be relative motion between this clip and the blower fan. So one of these is spinning with the motor and the other one is not. And look how loose this is. I can actually also move it axially by a good 1 or 2 millimeters up and down. So that's not brilliant. So what it looks like is happening is, if you remember, this is upside down at the moment. Gravity would, over time, and as it spins and it's loose, it's going to find its way on the end of the shaft. And if we look, I can spin this fan without spinning the motor shaft because it is no longer on the splines. See that there? So we need to come up with a fix to get rid of this clip, or at least make a better clip that holds it into position, because I can press this down as far as I want, but it's still crappy. So I saw other videos of shop vac repairs where there was a nut on here that held this on, and you would just zip it off with an impact. That seems like a way better solution. This seems like it was a manufacturing shortcut to assemble them more easily, but they did not have serviceability or longevity in mind. So if you're having the same problem We're going to come back to that. I'm going to propose a more permanent solution. But on the other half of the motor, this is the guy that usually causes all the noise. And this is not a bearing, it's actually a bronze bushing. And I'm going to take this apart further. We're going to get into that, look at it, study the design, and then again propose a better solution. To get into that, there are 3 more torque screws that need to come out. If we look down around here, you'll see 2 here. Mine are just all a little bit rusty, so they're a little bit hard to see with the lighting. And there's a 3rd one right down here. Again, you can't see it, but there's going to be 3 total. Let's take that out. That'll allow us to get rid of this big plastic shroud thing, and then we'll just have mostly the motor assembly. Removing those 3 torque screws allows you to just remove this piece from the back, which also contains the switch as part of it. So just be kind of careful not to damage the wires. But this allows you to see kind of the general area around the motor. We can remove the motor fully by going in from the other side, but at the moment, let's just take a look at this bearing cage. So there's 2 torque screws, 1 on each side. One of them also has what I'm assuming is a ground. If we followed this back, I suspect this green wire would have continuity here because it does not go to the switch. Let's remember to put that back when we're done, but let's zip off these 2 torque screws and inspect the snout bearing. So those screws have been removed. Pretty long. There's 1 there and 1 there. Try not to lose track of these. But anyway, you can see it's just nothing. There's no features on the shaft. It's just a smooth shaft, and then on here, I'll clean this up before we take a deep dive into it, but as you can see, there's some sort of a swedged lip here, crimped over something, which is the bushing assembly. So what I'm going to do is clean this up, we'll take a better look at it, and then take it apart. Got it sort of cleaned up just enough to show that it's definitely some sort of a bronze bushing, possibly an oil impregnated type, but in either case it's definitely not a bearing in the same way that we think about things like ball bearings or roller bearings. So what I'm going to do is try and work my way around this lip and uncrimp that cage that's holding it in place. I already know from doing some other reading that if I were to take this apart, it would just be like a little brass bushing that floats in the center. It's not brass all the way across this this opening. It's just a small little piece of brass or bronze in the middle, and there's some sort of fabric or sponge material around it that probably serves 2 purposes. One, to act as an oil reservoir, so it would kind of hold on to oil, and that might kind of diffuse through the oilite bronze. I don't know if that's how long of a process that takes in reality, but it might just kind of trickle into the mix. And it also probably allows this to float. Like, if I would bet you that there's a little bit of tolerance. So if the motor shaft wasn't perfectly true, or the other bearing in the back wasn't perfectly centered, this would have a little bit of slop or misalignment tolerated as it floats inside this cage here. So anyway, my proposal to fix this, and this is not my original idea, I actually saw this on another guy's YouTube video, is to use a 608 size bearing. As you can see, there's room in here for a proper bearing, and this is a 608 ZZ. You can get any kind of 608 as long as it's, I'd suggest, shielded for obvious reasons, keep the crap out. A ZZ, if you're not familiar with it, is a double metal shield. So it's 2Z because it's on both sides, ZZ. A 608 2RS bearing is going to have those they're kind of some sort of polymer seal that is just pressed into place on the front. And you've probably seen those on things like skateboard bearings and similar things like that. But 608 refers to the size, and then the 2RS or 2Z refers to the shielding. So a 608 is the right size mechanically. And let me try, oh yeah. So it's an 8mm shaft. It's a little bit of run out, but I think that's gonna be okay. This is probably, it probably would have been a tight fit, except that it was chewing up on this bushing here. So I'm just gonna use some bearing stick. I'll come back to that later. I'm not gonna get into those kind of details right now, but I'm going to essentially get this in there. And if I have to make a sort of a shim, I will make that. And I want this to be a relatively snug fit inside of here. So after I kind of get this swedging out of the way, then we'll come back. So I attacked it with the Nip-X on this edge here, made a nice little mess of it in the process on the piece and on my floor. But you can kind of see the edges now of that perforated little insert piece. So I think at this point I'm gonna be able to get something under there like a small flathead or a pick and just kind of deform it and bend it out of the way, out from under the rest of this little crimped over lip. So do that, may use a Dremel and just try and cut the rest of it off flush, but I'll let you know when this is all out. And so literally 5 seconds ago, I just pulled it out. Put that down. I have not looked at this yet until now, but yeah, I can see that sponge material around the edges, and let's see if this little, yeah, it just comes out. Little bronze piece. It's like a little ferrule type of thing. Yeah. Sorry for my hand shaking, guys. I just had a cup of coffee about 30 minutes ago. But yeah, so that's toasted. Let's look at the inside here. Let's see. And this is, whatever was in here is just deteriorated. I'm afraid to, oh no. Okay, I just touched it. Yeah, that's some kind of, it's almost like a really deteriorated cork or sponge kind of thing. It's brittle, kind of like charcoal and kind of porous. But at least it, you know, looks like the interior, it's gonna be workable. So let me clean this up. We'll come back and then I'll superimpose the bearing. So that's all cleaned up now. There's our bore. And here's the 608 bearing. Goes right in. Now there is a little bit of slop in it, but I'm going to try something. You could fabricate, you could use some shim stock, like really thin copper or brass or something, and cut it out with snips and kind of make like a strip and wrap it around and then just kind of hammer this in. And I might do that. But I want to try something else first because this is really close. Like it's only a few thous each way. So I'm going to introduce the bearing stake. And I've used these on wheel bearings that were, you know, I was trying to install wheel bearings on an older car where the shaft had some wear on it and they weren't really a good fit. This can take up a few thous of slop between a bearing race and wherever it's supposed to go. And it's kind of like a glue stick. This is old. I've had this for over 5 or 6 years. And you kind of just smear it on, push it in, and then let it set up. I like to rotate it so that it sort of aligns and it's not going to be skewed to one side or the other. So let me try that, see if that works. If not, then I'll come back to the shim stock type of approach. So this is going to probably take about, I'm going to give it an hour or so to cure. While that's curing, let's turn our attention back to this side to fix this problem with the fan. I've already popped this clip back off. It wasn't very hard because it was buggered already, but it's just as you can see, just a crappy little piece of stamped steel, and we should consider that a one-time use item. I didn't learn from my mistake. So with that spring clip off, you can remove the blower fan. You can see some splines here. It's really similar to sort of a clutch disc type of idea, even as the center riveted in. So if you look on the motor shaft, you'll see the 2 dogs. So if you wanted to remove the motor completely from the housing, you can remove these 2 screws and the whole thing comes out. That's a good chance to service the other bearing on the other side of the motor. And that one is a proper ball bearing, and it's actually a 608 size as well, I believe. So if you wanted to replace it, you could. It just might be a lot of work because you'll have to use probably some sort of a puller or press to get it on and off the shaft. So I'm not going to go into it. I already took mine apart. Mine is in good health. I peeled back the seal on it, and I added some heavy duty oil and put the shielding back on the side of the bearing. So that bearing is fine in my case. In your case, it's probably the same way. It's a proper bearing. So back on topic though, for this, what I'd like to do is I'm going to get a M8 die and cut threads onto this shaft, and then just use a nut on top of this. There's not any groove for me to add a C-clip or anything, so it seems like a reasonable idea. I'm gonna try it and let you know. If it's not working, then I'll go to plan B. So I've got my threads cut on here. These are M8 by 1.25 millimeters. And as you can see, I've taken it apart a little bit more by removing those 2 screws from the top. I was having an issue where I kind of underestimated, or I should say I just didn't think about how much force it takes when you cut threads. So there was no way to hold the shaft stationary. So I found that the easiest thing was a pair of vice grips on the shaft. But an earlier attempt that involved me sticking a screw through the fan blade did not go well. So now I have a long and annoying job ahead of me to straighten all these fins back out and hope that I didn't mess anything else up. So let that be a learning for you if you do the same thing. Vice grips on the shaft. Unfortunately, it is where that bearing is eventually going to go on the tip. But I think I'll be able to just use some emery cloth if there's any gouges from the vice grip. I don't really see any better option. So anyway, yep, this turned out nicely. We've got I'm just gonna use a Nylock M8 bolt, or M8 nut, I mean. Got a million of these, just from working on cars over the years. So let me put this all back together. Let me inspect that I didn't damage any of these wires going to the brushes or coils or anything. It looks like everything is intact. This is a good time to inspect your brushes as well. And if you do want to service that back bearing, it's right here. And all you would do is you would just drive it out of this little plastic cage. It's really easy to do. Again, I'm not going to show it because I already did to mine, and I put some heavy duty oil in there. But if you want to do it, this is the time. So the motor is back inside this housing. These 2 screws are back in. What I'm going to do now is just check that everything is happy. So that goes on there. And then I'm going to install my lock nut. Let me go get the right socket for this. And again, I'm going to counter hold the shaft with the vice grips as I tighten this down. Now that's all together. No more weebly wobbly, and 0 play along the shaft in this direction. So I think all that's left to do next is to reinstate that front little snout bearing that we've modified, and in general, reassemble the whole unit and test it out. Got the motor unit put back together. I did end up getting those fins straightened out. It actually wasn't that big of a deal. And of course, there's our new bearing cage with the bearings installed. Everything is cured. It spins nice and smooth. See on this side. Yeah, everything is just very nice, and I don't know. I'm really happy with this. So anyway, I'm not going to go through the final reassembly, because it's this just reverse of taking it apart. The next clip will probably be a test of it. So we'll see if all of this actually worked. So we're outside now to test after we've made those modifications. Oh yeah. That's what I was expecting.